All right, welcome to day 3. Your work for today, you're doing the yellow packet, number 76 to 92. You'll notice there's a big jump for some reason on the AP when they switch from no calculator to calculator. There's a big gap in the question numbers. And then that you're doing 2016 number 5 and 6. Make sure for those you're doing it on a separate sheet of paper for the 5 and 6. I would say do them all on a separate sheet of paper, but definitely the 5 and 6. So what I would like you to do with your homework answers is pause for a second, check your answers, and then on the video, I'm going to go through and I'm going to talk through each one of the questions. You can skip ahead in the video just to listen to the ones that you got wrong. And then after going over the multiple choice, I'll go over the free response. So if you happen to get all the multiple choice correct, just skip ahead in the video to the free response ones. So again, you can pause, check each of those answers, and then skip ahead. The other thing I have listed here, so the first 5 columns there are people who scored 5, 4, 3, 2, 1 on the AP and the percent that got them correct, and then the total percentage of people that got the questions correct. So the ones you got wrong, you can see are they questions that lots of people got wrong or that lots of people got right. So like for example, question 28, only 13% overall got that question correct. And even the people that got 5s on the AP, only a quarter of them were getting it correct. Question 22 is another low one. Notice the people that got 5s on the AP, only 31% of them are getting it correct. Because we want all of you to be in the 4s and 5s column. So kind of comparing there. Whereas say like a question like 23, 80% of people that had 5s got that correct. So again, check those answers, skip ahead to the multiple choice ones you missed, and I'll explain how to do them, and then skip ahead to the 2 free response ones at the end of the video. That's all this video will be, and then the rest of the day is just working on those problems for the assignment. All right, so 15, we just want to do the second derivative and then subroot in square root of e. So start out, we had to do a chain rule. So 2 out front, natural log of x raised to the first, and times the derivative of the inside, which is 1 over x. I then neatened that up and wrote it as 2 natural log x over x. To do the second derivative, we had to do a quotient rule. After doing the quotient rule, I chose to just neaten it up a little bit. The x times 2 over x just gives us 2. And then we've got to sub in the square root of e. So natural log of square root of e, because that's e to the 1/2, that just becomes a half, times the -2 just becomes a -1. And then the 2 minus 1 will give us 1 in the numerator. And in the denominator, squaring the square root just gives us e. So that's how we get the 1 over e. For 16, I think the easiest way to think of this is, notice we're raised to the n. So think of it as, how can we turn that into a geometric? Well, we know geometric converges if absolute value of r is less than 1. So we want that inside to be something smaller than 1. For it to be smaller than 1, the denominator would have to be greater than 2. To make the denominator greater than 2, we would want x, if we're thinking positives, we would want x to be bigger than a positive 1. And if we want negatives, we would want it to be less than -1. That would ensure that we basically have inside the parentheses there some value whose absolute value is less than 1. So choice D. So when we take the derivative of f, we've got h of x squared minus 3. So we've got to do a chain rule. So you got h prime x squared minus 3 times the derivative of the inside, which was 2x. Then just sub in the 2, so we'll get h prime of 1 times 4. So that's choice B. So if we have a line that's tangent to the graph, we know where at the point where they meet, they should share the same slope. So take the derivative of the x squared plus 3x plus 1, we get 2x plus 3. In the top equation, we can rearrange that to be y equals negative x plus k. So that means the slope of the tangent line has a slope of -1, always. So there must be some point on the graph that has a slope of -1. So take its derivative, the 2x plus 3, set it equal to -1, and we can find for what value of x it will have that slope. And we get that it's when x is equal to -2. Well, the tangent line and the original graph should share the coordinate at the point of tangency. So sub that x equals -2 into the parabola equation, we get y is -1. So it must be at the point -2, -1 that they share a common point. So then take that -2, -1, fill it in for x and y in the other equation, and that determines that k is a -3. In 19, we have to do partial fractions. So I kind of skipped the first step where I wrote it as a over 2x minus 3 and b over x plus 2, and just already did the multiplying through. Remember to pick strategic values of x. If you let x equal -2, you end up getting that b is 2 eventually. Let x equal either 3 halves or 1.5, you eventually get a is 3. Then do your integral. That's going to be a natural log with a little u substitution. So in that first one, I needed a correction of a half out front. And in the second one, I needed no correction because the coefficient was 1. In 20, we want to recognize that they're all positive. We have all the exponents and all the factorials. So we want to recognize that that's our Maclaurin series for e to the x. But in place of all the x's, we subbed in natural log of 2. So e to the natural log of 2 is the same as just saying 2, so that's why it's choice C. So if the velocity of the particle is increasing, that means on the velocity graph, we want a positive slope. That means the second derivative would have to be positive. So in the original function, if the second derivative is positive, that means concave up. We are concave up on the interval of 0 to 2 because they told us the inflection point was at 2, so that's choice A. 22 was probably a tricky one. We had in the integral on the left, we had to do integration by parts. So our u we wanted to be g of x because that's something we could take the derivative of, and our dv we wanted to be f prime x. So you do your derivative of g, do your antiderivative of f prime. So then our uv we just have f times g, and we'll end up evaluating that from 1 to 0, and then we still have minus the integral of our v du. So that gives us f g prime of x. Well, we know that that expression in the third line there is supposed to equal 5. And notice the integral that's still left is what we're trying to solve for. So we can just do our subbing in of the 1 and 0. So if we sub in 1, we'll have f of 1, which is 4, times g of 1, which is 3, and then minus f of 0, which is just 2, times g of 0, which is -4, and then minus the integral we're looking for, and we know that should equal 5. So essentially what we could do is subtract the 5 over to the left, add the integral over to the right, and that tells us the integral we were looking for is just equal to 15. So that would be considered a pretty challenging question. In 23, start with your Maclaurin for sine, where we have all the odd powers, odd factorials, and we're alternating signs. Sub in a 2x for all the x's, then multiply by x, and notice that would match with choice E. So P is like our Y value here. So we want to recognize that that looks like a logistic function. Logistic functions differential equations are a constant times a Y value, and then in the parentheses is the carrying capacity minus that Y value. So we want something based on our variables, we would want a KP times 200 minus P because it is a carrying capacity of 200. So notice all of our choices, it's distributed through. So we would want a minus p squared to come in the second part. So because it's got to be a minus and a p squared, that tells us it's got to be choice A or choice B. Well, because of the 200, whatever k is, the coefficient of the p term should be 200 times greater than the coefficient of the p squared part. So that 200 means basically double it and move the decimal point over twice. So A is what shows that. If you doubled it and moved the decimal right twice, that gives you the 0.2 when the coefficient of the p squared is the minus 0.001. So if it is differentiable, if we take our derivative of each of them, they should be equal. And because it's differentiable, it must be continuous. So we can also take the original functions and they should be equal. Now I say they should be equal when x is equal to 2. So that original equation I took there, I took the cx plus d, and if you fill in 2, that'll give you 2c plus d. And that should be equal to when you sub in 2 to the bottom equation, which gives you the 4 minus 2c. Well, then take the derivative of each of those. You just get c, and you get 2x minus c. We'll replace the x with 2, and that gives you c equals 4 minus c over on the right there. You can solve that c is 2, sub back into the first equation to get that d is negative 4, and then they wanted c plus d, so 2 plus a negative 4 gives you negative 2. So when you do a area of a polar function, we have 1/2 times our radius squared. So because our radius was sine squared, when we square that, we know we're going to have a sine to the fourth. So that eliminates its choices A and B. If you were going to do the full loops of things, we would have to go from 0 to 2 pi. But because they're the same, we can just double it and only go from 0 to pi. So that's why it ends up as choice D. If they had a 1/2 0 to 2 pi of sine 4 theta, that's something that could work too, but they don't have that as an option. So they have the option where we just double it because both of them are the same. Now 27, the graphs were pretty hard to read in the copy that was there. So first off, the scale was pretty challenging. It was going out to 2 and negative 2 in each direction. So here's all the graphs. Our differential equation there, we have y squared minus 1. So one thing to note about that is if your differential equation is y squared minus 1, the x value does not change the slope of the tangent line at all. So as you move left and right, it should be the same slope for all of them. So like in B, as you move left and right, notice those slopes are changing. So that doesn't work. A looks like the slopes are constant as you move left and right, so that's a possibility. In C, the slopes are changing as you move left to right. You got some negatives, some positives. D, the shape of the particular solution looks like a parabolish type thing. So as you move left and right, those slopes are changing. And then the last one looks kind of exponential-ish. So again, so as you move left to right, they do look consistent in E. So it's got to be either E or A. And the way to decide between them is our slope should be 0 when we have y is equal to 1 or negative 1. Well, in E, it looks like the slopes are going to be 0 when y is 0. In A, they never actually show like the directly at 1, but if you notice, they're flattening out kind of here. And the other way to recognize it is between negative 1 and 1, notice this all has negative slopes, where outside of there, it's positive slopes. So on the AP, if you got something like this, they would give you probably a nicer copy than this one was. All right, and then 28. So if we've got a speed of 2 square root of 10, we're working with a parametric here. This is our speed equation over here. So we know square root of the x component squared plus the y component squared should equal 2 square root of 10. If we're moving along the parabola, x squared minus x, dy over dx for that should equal, maybe I should label that this is dy over dx, is 2x minus 1. Well, dy over dx can also be found by doing dy over dt divided by dx over dt. So we know dy over dt over dx over dt at x equals 2 should equal this. Because this is our derivative at every point, if we fill in 2, it should equal 3. Well, that now gives us dy over dt times 3 dx over dt. And what we want to do is in our speed function, we want to make it so only dy over dt is the thing we don't know. So we want to get dx over dt by itself, so divide the 3 over, and we know dx over dt is the same as 1/3 dy over dt. Well, now we can do a substitution. If we square the 1/3 dy over dt, we end up getting 1/9 dy over dt all squared. If you add those together, it's 1/9 plus 9/9 dy over dt squares. So that's really square root of 10/9 times the square root of dy over dt squared. And this is still equal to the 2 square root of 10. Well, let me neaten that up a little. That's square root of 10 over 3. That's going to be dy over dt equals 2 square root of 10. If you multiply the 3 over, that'll give you 6 square root of 10. So you have square root of 10 dy over dt equals 6 square root of 10. And when you divide the square root of 10s over, that's where you get the dy over dt is just 6. So you can see that's a pretty challenging question. That's why a lot of people do not get it correct. All right, moving to the free response ones, 2016, number 3. At x equals 10, notice the graph of f would be the derivative graph. And at 10, that derivative, which is f is the derivative of g, I should specify, is going negative to negative. So notice I just showed a little number line, made sure I labeled the g prime and the x. You could have also said f of x instead of g prime of x because they're the same thing. And then just write a little explanation. So g of x had neither, since to the left and to the right, you could have either said g of x was decreasing, or you could have said g prime or f of x was negative. So make sure you don't say it in your explanation, specify what function you're talking about. So we would have a point of inflection if the second derivative changes signs. The second derivative can be found by looking at the slope of f, which is the first derivative. So at 4, left of it there's a positive slope, right of it there's a negative slope. So therefore there is an inflection point at x equals 4 because g double prime switches from positive to negative. And really you just needed to say that g double prime switches signs there. For inflection points, it doesn't matter the direction that it switches. All right, 3C, we've got to take all of the places where the derivative is 0 or the derivative doesn't exist. Our derivative is existing everywhere in the graph of f, so we just have to find where it's 0, and then we also got the endpoints on there. So negative 4 and 12 are on the number line because of the endpoints. Then you got all the zeros, the negative 2, 2, 6, and 10. From the graph of f, you can decide if it's negative or positive. That's where I get my minuses and pluses. Make sure you've got your labels. You've got x. This one can either be written as g prime or you could have called it f of x. We want the absolute min. The absolute min, we need to check the local mins and the endpoints. So tell about your locals first. So the conclusions you can make is x equals 6 is a local max. And you can say because either g prime or f switch from positive to negative, and then negative 2 is a local min because it switches because g prime switches from negative to positive. So we have to check in the function g are endpoints and the local min. So g of negative 4, that's one of our endpoints. By subbing it into the g integral there, that would be 2 to negative 4. Well, we like the smaller number on the bottom, so when you switch them, notice it puts a minus out front. So we're doing the negation and then doing negative 4 to 2. You're just doing areas of triangles there. That's where I got those numbers on the right, and you get negative 4 back. Then do g of 12 from 2 to 12. So you're just doing areas of triangles again. You get negative 4. And then for g of negative 2, again, we're going to have to reverse the bounds. So that puts the minus out front. Do your areas of your triangles. You eventually get negative 8. So our absolute minimum is negative 8. Now, if you had to do an absolute max, or I guess did they ask? Yes. So absolute max, you're just checking those endpoints again, which we already knew the values for negative 4 and 12, and then you just have to do it at 6. You get 8, so the absolute maximum is just 8. And then lastly, in D, we want to know when is the graph of G negative. Well, I think it's helpful to find the values of G at each of those critical values in the endpoints. We already knew the negative 4, the 8, and the negative 8 from our previous work in C. The integral from 2 to 2 is just 0, so that one was pretty easy. So really the 10 is the only other one you had to find, and that was 0. So then on that, based on that chart, we're negative from negative 4 to 2 and 10 to 12. And notice we wanted when it was less than or equal to 0, so that's why we have the square brackets on there. In 4, we got a differential equation. So the second derivative, we'd have 2x, and then we would have minus a half times dy over dx. It's like saying times a y prime. Replace the dy over dx with that original differential equation. And either of these would be full credit answers. I distributed just to neaten it up, but both of those would be in terms of just x and y, so either of those would be fine. At negative 2, 8, if we sub it into the original differential equation, the dy over dx equals x squared minus 1/2 x, you would get 4 minus 4, so you get 0. So we've got a slope of 0 based on our first derivative. If you take your answer from A and sub in the negative 2, 8, you end up getting negative 4. So that tells us it's concave down with a slope of 0, so that must be a relative maximum. And we would have to invoke the second derivative test there. So because it was a first derivative of 0 and a second derivative that was negative, that would lead to a maximum, a relative maximum by the second derivative test. AP exam really likes the second derivative test a lot. In C, we've got to do our limit. G of negative 1, they told us in the question was 2, so 2 minus 2 is 0 on top. Fill in negative 1 on the bottom, and you end up getting 0, so we got to do a L'Hopital's rule. So we'll get g prime of x on top. You got a little chain rule on the bottom, so you got 6 times x plus 1. We know from the first part of question B that not from the first part of B, because it's a different x value. Over here, take your dy over dx, sub in negative 1, and sub in the 2 for y, and notice we get 0. Sub in negative 1 for x on the bottom, we get 0 again, so we've got to do another set of L'Hopital's. So now in the numerator, take your answer from A, fill in the negative 1 for x and the 2 for y, you get negative 2 on top, 6 on the bottom, so we got negative a third. And the last one, we wanted 2 equal steps to get to 1, so that means we wanted to step by 0.5. So you got 0, 0.5, and 1. They told us that 2 was our y value at 0. So we're going to sub in 0 and 2 to our differential equation. Remember, the original differential equation was x squared minus 1/2 y. So when you sub in 0 and 2, that's where you get the negative 1. Multiply the negative 1 by our step size of 0.5, and we get negative 0.5. So that gets applied to the 2 that we just already had for the h of x value. So now that gives us 1.5. So take the 0.5 and the 1.5, sub it into our original differential equation. We get negative 1/2. Multiply that by our step size of 1/2. We get negative 1/4. Apply that to the y value we just had, and that gives us either 5/4 or 1.25. So for the rest of the day today, you're just working on your day 3 assignment questions. Take pictures of them, upload them to Schoology. Have a good rest of your day.